Introducing the CCC charger, a 3-channel lithium battery charger with USB-C connector. Is this a big invention? Not at all, but here's the story, how it was born and how can you get your own. This project was born because of 3 reasons. The lack of USB-C compliant chargers, no cheap and simple multi-channel chargers on the market, and elf bars, yes, vaping. Or to be more precise, the amount of e-waste we could save. When disposable vape pens popped up, many of us asked the question, how do they work? They need a power source. Some of my friends collected their used vapes, so I just asked for one, and got a bunch of them. Disassembling one is not a big challenge, it's just messy because of the vape juice. The device is pretty simple. An integrated sensor, driver, and optional charge controller for some models, the heating coil, and the power source, a rechargeable lithium-ion battery. At their scale, it makes sense to order the cheapest rechargeable batteries. The only problem is the amount of generated e-waste. These batteries are usually totally fine to recharge, but instead of that, they get thrown out. Vape pens are usually not refillable, so it makes sense to collect them and salvage the batteries. I processed a few of them, and the batteries range from a few hundred milliamps to a whopping 1.4 amp hours capacity. But if you salvage dozens of batteries, you will need a lot of time or a lot of chargers. I have some of those cheap charger circuits, but we need to charge many small cells at the same time. An average charger only has a few USB ports, and it's a limiting factor in our case. So copy-paste 3 charger circuits on a single PCB. We can do this because one charger only needs a relatively small current. Let me explain it. You can encounter a magic C number on some batteries. This shows how much amps it can give. Multiply this number with the capacity and you will get a current in amps. For example, this RC drone battery has 300 mAh capacity, 45C continuous discharge rate, and 90C burst discharge rate. Let's do the math. 0.3 amp hours multiplied by 45 means this battery can give you 13.5 amps continuously, and a double 27 amps for 1 to 3 seconds long bursts. But this is a really powerful battery pack. These numbers are shown because it's unusually high and is their selling point. Your average lithium cell is usually rated for only a few C for discharge, just like this random example I found. You can check out various battery manufacturers and download the datasheets. There are huge differences between cells, so don't just assume anything. Check the ratings first if possible. But even the cheapest lithium cells can be safely discharged at 1C. And charging? Luckily, almost every cell can be charged with 1C, and is considered normal charging in the lithium world, not fast charging. With older chemistries like nickel metal hydride, 0.1C charge current for 12 up to 16 hours is the normal charging process, and 1C is considered really fast charging, but only premium batteries can handle that. So 1C normal charging with lithium batteries is a huge upgrade. But back to our Salvage batteries. You can charge a random 300 mAh cell with 500 milliamps because it's not safe. And charging a 1.4 amp hour cell with 100 milliamps takes forever. Instead of a compromise, we need adjustable charging current. That's why I added the option to switch charging current between 100 and 500 milliamps. 500 milliamps is the maximum of the selected charger IC, and 100 milliamps is safe for smaller cells. I added a separate jumper for each cell, so you can charge batteries with different capacity at the same time. But beware, this is strictly for single cells. Never ever charge cells in series, because it will cause unexpected shorts. So, if you have a bunch of smaller batteries for your hobby projects or drones for example, get one. But this is an open project, I'm not selling it. I made the PCBs with PCBWay and they offer project sharing. You can download the Gerber files and they can also make your PCBs. I wholeheartedly recommend their services because I'm really satisfied with the results. Everything is listed on the project site, so you can order one or even make your own at home. Thanks for watching, consider subscribing and sharing the project.